Hello, everyone. Good morning, afternoon, and evening. Dear authors and invited guests, welcome to Technical Session 9G. My name is Alesha Mullah, and I will be the moderator for today's session. On behalf of Global Knowledge Research Foundation and GR Scholastic, it is my great pleasure to welcome you to the 11th International Conference on Information and Communication Technology for Intelligent Systems in 2026 in Bangkok, Thailand. The 11th edition of the conference is being organized in a hybrid mode. The physical event is being held today in Bangkok, and the virtual event is being held from 9th to 11th April via Zoom. I hope you will enjoy the knowledgeable and interactive sessions throughout the day. In this session, we will have 10 presentations. Each presenter will be given 10 minutes to present and 2 minutes for question and answer. On the 9-minute mark, I will raise a gentle reminder. There is another request to all the participants. Please stay connected with us till the closing remarks. If you have any query or update, then you can write it to me in the chat box. Just before we start the session, I would like to introduce you all to the chair for this session. Dr. Disha Vankade is currently an assistant professor at Vishwakarma Institute of Technology in Pune, India. She has 16 years of teaching experience. Her skills and expertise lie in machine learning, computer vision, artificial intelligence, and her research areas include deep learning and image processing in healthcare and agricultural domain. Ma'am, I would like to request you to please say a few words.
Good afternoon. Am I audible?
Yes, you are.
Yeah. Just a minute. So, yes, thank you. Thank you for the deep introduction. Hello.
Yes.
Am I audible?
Yes, ma'am.
Yeah. So, it is the great honor to privilege this as a session share here. Thank you to the organization for giving me this opportunity as a session share. Definitely, I'm looking forward for some insightful presentation as high quality research work may be done in today's all the researcher. So yes, please start the session.
All right. Thank you, ma'am. So without further ado, we'll begin with the first presentation for today. First, we will have Abir Paul, who will be presenting a hierarchical machine learning framework for drug supply chain management in healthcare. Abir, you may now begin.
Can I share the PPT? Okay, first of all, good afternoon, everyone. First of all, I want to thank you for ICTIS for giving me chance to present my work on a hierarchical machine learning framework for drug supply chain management system in healthcare. So first of all, I will give a brief discussion on the introduction and motivation of our work and also the objective of the work, and then we will follow to the methodology part and also the result and publication. So in the current era, drug supply chain management is critical in healthcare. In every places and you can say in many healthcare solutions and
Excuse me, Abir, your voice is not clearly audible.
Required for accurate demand forecast. So, hello.
Yes, we can hear
Hello.
you.
Okay, so for the insurance, okay, so accurate demand forecasting ensures the demand availability, reduce wastage, and better patient care. Demand is highly dynamic of the due to its seasonal variations and seasonal differences. and
Hello, Abhi.
changing the
Your voice is not. Hello.
hello, am I now audible
Yes.
clearly? Okay. Okay, so continuing the key challenges for designing a scalable and accurate forecasting system, it is one of the key challenges for demand forecasting and also capturing the regional demand variability with the overall demand stability. So for the project motivation for us was the growing complexity in the healthcare supply chains and increasing need of accurate demand forecasting. There are several limitations in the existing approaches. Also, we can say the gaps in the research, that the lack of hierarchical forecasting and need of combining the local insights plus global stability. There are many models which exist for demand forecasting, which is made by LSTM or CNN model. They are too complex for interpretable, and many models such as XGBoost, they are too simple that they cannot intersect the seasonal variations. So our main motivational goal is to improve the accuracy, supporting the multi-level decision making, and enhances the overall supply chain efficiency. So now so the objective of our project is clear: to develop a hierarchical machine learning framework to combine the multi-level, regional, and nationwide, and to accurately capture the seasonal patterns, time scales, and regional variations in drug consumption. To improve the forecasting performance, we are using the time series modeling. Here we have used SARIMA and data pre-processing and smoothing techniques to support data-driven decision making in procurement planning and inventory management and the resource allocations. So first I am going to the methodology part. First of all, we have collected the data. First step is data collection. So as there is a limitation of original data, we have created a mock data set which mimics the actual trends and historical data from 2015 to 2025. We have divided the dataset into two parts: nationwide dataset and region-wise dataset. So in the dataset for the nationwide, we have taken the date, drug name, region, and quantity distance. And in the region-wise dataset, we have taken the drug name, date, month, year, and quantity distance. Next, we have gone to the data processing part, where we have aggregated the total demand into the monthly basis. Next, we have done the data processing, which is a key step for our methodology. Here we have done two steps: smoothing and log transformation. First of all, smoothing, we have done the average of the current month plus two historic months. It preserves overall the trend and also remove the short-term fluctuations. And in the log transformation, due to the drug chemistry's heterospecificity behavior, there is we have done the log transformation. There are some months there is a very small data. So for stabilizing the overall data set, we have done this log transformation to compress the large data and stable the variance. Then we have gone to the model selection part. We have chosen the SARIMA model as it is a seasonal ARIMA. It handles both trends, seasonal, and patterns also. Then we have done the model configuration. So as we have done in a hierarchical basis, so we have made the two first national model and regional model. In the national model, we have select the parameters of SARIMA is 1, 2, 2 for the non-seasonal part and 0, 1, 1 for seasonal part. And in the regional model, we have done the parameters for 0, 1, 1 for non-seasonal and 0, 1, 1 for seasonal part. So after training the model, we have divided the whole dataset into two parts: train and test. We have trained the model based on 2015 to 2024 dataset and test on the 2025. Last, we have the evolution and filtering part. There is a adaptive error filtering part. there may be very small demands in the in the data sets. So for reducing that, we have maintained a threshold. Below that, we will consider that a very low demand. We have taken the quantile, 20 quantile, and 3 points for the data set for evaluating the data set. And for accuracy, for accuracy matrix cost, we have taken the MAPE, RMAC, and SMAPE. MAPE is mean absolute percentage error, RMAC is root mean square error, and SMAPE is symmetric mean absolute percentage error. Then the model forecast the next 12 months data. Next, we have come to the result part. The model we have done, there is a two-part nationwide forecasting model and a region-wise forecasting model. So in the nationwide forecasting performance, we can see that the mean of the MAP is 21.09% and SMAP is 22.21%, which is
I'm sorry to interrupt. You have a minute left.
okay. And in the region forecasting performance, the mean is 1.45 and 1.15. The error is very small for this model, and it is very reliable. Here we can show the graph also for the regional purpose, and there are seasonal error comparison and seasonal actual predicted demand graph. There the actual and predicted demand follows each other very closely. It seems it provides us a very clear virtual that the model is very good. Make a near perfect predictions. So as a conclusion, we can say that we have proposed that hierarchical forecasting framework and successfully combined the nationwide forecasting and regional forecasting. And the key result of our project is it has achieved a high accuracy at regional level and reliable performance at nationwide level and effective handling of seasonal demand patterns. Key benefits include the forecasting leverage, better inventory and procurement decision, reduce risk of stockouts and overstocking. So there are some mechanisms we have given based on which we have done our project work. Thank you.
Good presentation. Just let me know that public, what type of data set you are using for that?
Okay. In that case, there is no publicly available dataset for the drug inventory system. So we have mimicked the actual trends from several websites, and we have made a synthetic data.
Synthetic data.
Yes.
Okay. So what parameters you consider while creating the synthetic data?
So we have in the regional nationwide purpose, we have taken the drug name and month, year, date, and region and quantity distance for that month or date. And for the regional purpose, we have taken only the drug name, date, month, year, and quantity distance.
And machine learning algorithm is mostly used here in the hierarchical level.
Sorry, ma'am. I cannot hear you.
Yeah, which ML algorithm is used here?
Okay. We have used the SANIMA seasonal auto-regressive integrated moving average model.
And your model is performed well, right? You got the good accuracy. Your model is performed well.
Not able to hear.
What accuracy you got?
Can you repeat the question?
No. Just explain that what is the accuracy you got it.
Anyone cannot hear clearly.
Accuracy, accuracy. Hmm.
Can you ask the question in the chat so that I can understand
Okay, let me
from here clearly?
check after this. Yeah. Okay, Abhi. Good. Thank you.
All right, so now we'll move on to the next presentation. So next up, we will have P. Saranya Durga, who will be presenting Innovate Hub, a secure and scalable portal for monitoring research and innovation excellence in educational institutions. You may now begin.
Okay, ma'am. Is the screen audible? Chichi visible?
Yeah, we can see.
Yes.
Uh, Good afternoon, everyone. I am Pajuri Saranyadurga, along with my team members. Today, we are here to present our project titled Innovate Hub, a unified portal for innovation insights and research. This project has been developed under the guidance of Devi Priya. The main objective of this project is it is a centralized platform that can effectively track, manage, and showcase innovation and research related activities within an institution in a structured and a meaningful way. And coming to the today's agenda, I explain the project abstract, introduction, existing system, and literature survey, proposed solution, and the algorithms used in this. And coming to the abstract, Innovate Hub it is a web-based platform which is designed to bring all together innovation related data into one unified portal, and it collects information from different sources such as research, publication, patents, grants, and awards and startup activities, and transforming all that activities into a meaningful interactive dashboards and visualization. And it also includes a role based access for students, faculty, and administrators. And additionally, it includes features like recognition and rewards and feedback, which helps in monitoring users and encouraging them to participate in innovation related activities. And coming to introduction, innovation plays a major role in driving both the success of any education institution. However, measuring all of the innovation related data is a not simple task because the data is often segregated through different platforms and formats. So this results in poor visibility of the achievements and makes it difficult for institution to evaluate their performance. So therefore, there is a strong need for centralized and intelligent system that can organize all this data and provide a clear and complete picture of innovation activities. And there are some existing portals. They are ResearchGate, Scopus, and Sodhganga. All these platforms are very useful, but they are limited in scope. For example, ResearchGate mainly focuses on the research papers and connect the researchers. Coming to limitations, it does not focus on any patents or grants or awards. However, none of these platforms offer a complete solution for tracking all the innovation activities in one place. They also lack features like real time dashboards and security issues and recognition systems, etc. As a result, to provide a comprehensive view of this innovation, we have developed this web based portal. And coming to literature survey, we have studied some previous research systems, and all of them are provide real time performance and indicators and data visualization, while some of them focus on multi user accesses. Coming to proposed solution, this portal is made using a main stack, which is used to track the measure and showcase innovation excellence in institution, and it also provides secure authentication and with role based access, and the system integrates data from various innovation sources and provides a unified portal for tracking and analysis. It includes secure authentication with a role-based access, ensuring that different users can access only that relevant data to them. And it also features in interactive dashboards and present data in visual and easy to understand format. In addition to it, we also included the recognition feedback mechanism that will help the users and promote a culture of innovation within the any institution. And the algorithms used in this are for a password security, we have used bcrypt to hash the user passwords before storing into the database. And second one is for authentication and authorization, we have used JSON web tokens for secure user authentication. And student wise data isolation, for every student and faculty we have assigned their owner ID and owner role. Based on that, that particular data will be available to them. And coming to document storage, we have used SHA-256 hashing method that prevents file name guessing and duplicate uploads. And also for a faculty login, we have implemented a OTP through node mailer. When a faculty enters his mail ID, the OTP is directly sent to his mail. And also we have used a face recognition for a document submission for research and SAH, and we have used a face API JavaScript for that. And coming to workflow, first there is an user authentication where admin, faculty and student can log in with their role-based access. And next one is data collection. The all type of data like research projects, patents, grants and publication awards, all the data is gathered through forms. And next, data processing and storage is validated, organized securely and stored in MongoDB database. And for analytics and visualization, we have used Chart.js, where the data is shown in dashboards or graphs. As a recognition reward feature, we issued a certificate for each and every student and faculty for top contributors. And coming to the architecture, this is the Innovate Hub architecture, where there are three users like student, faculty, administrator, and user interface and face verification and submission of data. And additionally, we have deployed this website into AWS, where we have used EC2 and S3. The S3 is used for document secure document storage. Coming to the technology stack, all this portal is implemented using MenStack. For front end, we have used React.js, and for backend, we have used Node.js and Express.js, and the database is the MongoDB. And for authentication, we have used JWT based role management. And for visualization, we have used eCharts and Chart.js for dashboards. This is the website we have developed. This is the admin panel where the admin can see all the data submitted by students and faculty. This is the student dashboard where the student can upload all related data like research papers, started activities and publication. For research papers, we have implemented a face verification. Through face verification, only the students can upload their data. This is a faculty panel, and the faculty and students who submitted the data, for top contributors, the automatic certificate generation will be done by the admin. That certificate will be issued in their respective dashboards. In conclusion, Innovate Hub provides an effective solution for managing and showcasing innovation and research activities in institution. It offers a centralized platform with secure access and real-time analytics and user-friendly dashboards. By integrating data from multiple sources and highlighting achievements, it promotes transparency, collaboration, and continuous improvement. The system not only helps in tracking innovation but also encourages the individuals and the teams to contribute more actively and ultimately enhancing the overall growth and reputation of the institution. This is all about the project. Thank you.
Durga, I have questions related to this platform which you have built.
Okay, ma'am.
Yeah. Does this platform integrated with external databases like Scopus, Web of Science, or Google Scholar?
No, ma'am. We have designed like only not external databases are used, ma'am, in this.
Then how you can validate or authenticate that this paper is Scopus indexed, or Web of Science indexed? Yes, ASC.
Means we have kept only like a form type, ma'am,
Yeah.
not
But
authenticated like Scopus or.
yeah, but we require the authentication this platform related because this platform is good for
Uh,
your institute purpose or any ERP related things, which is every uh, colleges they have, right? We can
yes,
integrate this particular platform into the ERP. But we need to be some things which require to be validated, right?
yes, ma'am.
So you can try this that you can integrate with external databases or Google Scholar, this focus in paper science.
Okay, ma'am.
Also, one more suggestion that is there any AI technique is used here for predicting something, predicting any agentic things, agentic AI related things?
Ma'am, any at first
Such
we have
as,
uh,
for example, if any faculty or any faculty we can put here is
uh,
not performing, so something is need to be till you can do these things, or you can do the collaborative things, or we need to be encourage them to do that things because your performance is low, your KPI is low.
okay.
Yeah, only a repository is not workable right now. Such a things is already available in each and every institute. So we have to give some predictive analytics to
Okay.
individual performer and also add to integrate the external databases. Otherwise, your platform is good for this. Okay.
Okay, ma'am. Thank you.
Yeah.
Okay.
All right, so now we move on to the next presentation. So next up, we have Gagandeep Malhotra, who will be presenting Adaptive Per-Node Federated Deep Queue Learning for Anti-Jamming Spectrum Coordination in Tactical Electronic Warfare Networks. Gagandeep, you may now begin your presentation.
Good morning. Just give me a second. I'll just be sharing it. Is the screen visible and in the presentation mode?
Yes, it is.
Okay. Good morning. Good afternoon, everyone there. And thank you for the opportunity to present our work. The title of this paper is Adaptive Per-Node Federated Deep Queue Learning for Anti-Jamming Spectrum Coordination in Tactical Electronic Warfare Network. It stems from my work. I've been working on this for many, many years now. And ma'am, at its core, this research addresses a very practical battlefield problem. That is, how do we maintain reliable communication when the spectrum is crowded, fast changing, and actively contested by jamming? In such environments, fixed spectrum policies are often too rigid, and centralized control is often too slow or too communication heavy, we can say. So the idea behind our work is to move towards a learning-driven, decentralized, resilient approach. So we propose adaptive federated deep queue network or AFDQN, where each tactical radio learns from its own local operating conditions, while the overall network still improves through periodic federated coordination. So that is the central theme that I'll be developing through this presentation. Coming on to the motivation and the problem statement, modern electronic warfare environments are extremely challenging because of friendly radios, UAV links, radars, and hostile jammers all competing over the limited spectrum resources that are available at the given time. Now, when we add mobility, bursty mission traffic, intermittent connectivity, and the environment actually becomes non-stationary, partially observable, and we can call it adversarial. In such a setting, static channel plans and heuristic policies simply cannot keep up with the rapidly changing SINR congestion and the jammer behavior. So we need a system that can adapt online rather than rely on fixed rules. This is where reinforcement learning becomes very useful because it learns through interaction with the environment. At the same time, federated learning becomes valuable because it allows distributed improvement across nodes without actually taking the raw data sharing. Therefore, our work combines both ideas of anti-jamming spectrum coordination in tactical networks. Coming on to the main idea itself, the central idea of a work is simple but powerful. Each tactical radio learns from its own local experience, but periodic federated aggregation allows the entire network to improve collectively. In other words, learning is local, but improvement is global. Our contributions are fourfolded here. First, we designed a per-node adaptive FDQN framework in an NS3-based electronic warfare environment, where each node trains its own DQN from locally observed conditions. Second, we introduced federated aggregation for anti-jamming coordination so that a central server can combine client models even when participation is partial or connectivity is intermittent, which is again a realistic EW scenario. This is how it works. Third, we built a realistic EW simulation environment with mobility, sweep jamming, bursty traffic, congestion hotspot, and flow monitor-based measurements of delay, jitter, and packet loss. Finally, we implemented a complete end-to-end framework using NS 3.4, Python, PyTorch, which does the DQN training and the federated model exchange. So it is more than a concept, it's reproducible and operationally relevant system. Now, coming on to why AF-DQN and why we couldn't work with RL and FL separately. So if we use only conventional reinforcement learning, then training often becomes centralized, and that is not ideal for tactical networks because it increases communication burden and dependence on stable connectivity, which may not be there. On the other hand, if we use federated learning alone, we still do not fully solve the real-time decision problem of spectrum coordination under jamming because we don't know what is happening on the environment on that side. That's why our proposed AF-DQN combines the strengths of both. The key distinction is that our framework is not merely FDQN, it is adaptive FDQN. The server monitors indicators such as SINR volatility, jammer activity, and backlog instability, and then chooses an aggregation strategy suited to the environment. It can use Fed average in stable conditions, coordinate-wise median under inconsistent or suspicious updates, and attention-weighted aggregation when mobility or bursty traffics are demonstrated. That adaptive aggregation is what makes this framework more robust under dynamic EW conditions. Coming on to the proposed architecture, the proposed architecture has three main components. At the edge, we have tactical nodes, which act as independent federated DQN clients. Each client observes its own local states, including matrices such as SINR, QLL, packet drop, etc. Based on this state, it trains a local DQN and which learns the spectrum action that it must take under the given EW conditions. The second component is the adaptive aggregation server, which periodically receives model updates from the client and decides which aggregation rule it must use. The third component is the shared global model, which is redistributed to the client after aggregation so that all nodes benefit from the collective learning. Now, we demonstrate the simulation environment that we have used. To evaluate the framework, we used a high-fidelity simulation environment that combines NS 3.4 for wireless network emulation with a multi-client AFDQN framework written in Python. The network models a 60-node mobile IEEE 802.11n mesh, which provides a much more realistic tactical communication setting than a simplified abstract model. Node movement is represented using the random waypoint mobility pattern, and the hostile conditions are introduced through sweep and reactive jammers that degrade the SINR. We also created three different types of traffic. So 30% are bursty video traffic, 20% is delay sensitive VoIP, and 50% is best effort background traffic. So performance is monitored using flow monitor, which checks for throughput, delay, jitter, and packet loss. Just give me a second. Okay. Each radio node operates, it's a closed loop how the complete system moves. Each radio node operates as a FD-equivalent client that extracts its local state from the matrices, such as instantaneous SINR, queue levels, packet drop, delay, and jitter. This information is converted into a state vector for each episode. Based on that local state, the node's DQN selects an action, such as which channel to select and what to do when it is applied during the next NS3 cycle. So the system works in a closed loop between the simulator and the learning agent. The reward is designed to encourage higher packet delivery ratio, higher throughput, stable SINR under jamming, lower delay, lower queue buildup, and fairness across flows. We evaluated 3 approaches. First is the Fed average, then the robust median FDQN, and the proposed AFDQN. The results show that AFDQN performs best across main performance indicators. In the packet delivery ratio plot, AFDQN consistently achieves the highest PDR over the simulation episode, showing that it is better able to maintain reliable communication under jamming. In the throughput plot, AFDQN also delivers the highest average throughput, which means it is exploiting favorable spectrum opportunities more effectively than the others. In the convergence plot, this is especially important. Here, if you see, the Fed average remains almost flat, which is a limited learning under changing jamming conditions. Robust median improves somewhat, but it adapts much slower. And in contrast, the AFDQN shows a clear and steady upward trend, indicating faster convergence and better stability over time. The ablation insights is important here. Fed average behaves like a weakly adaptive baseline under dynamic EW conditions. Robust median improves resilience to outliers, but because its aggregation rule is still fixed, that's there, it adapts slowly when the environment keeps shifting. AFDQN performs best because it combines local per node intelligence and federated coordination and adaptive aggregation. So the gains come out from the reinforcement learning plus the federated learning. So that is what the model is all about. In terms of complexity, both a robust median and AFDQN use the same DQN structure. So computationally load, there is no difference here. The key difference lies in the computational behavior. Robust median follows a fixed synchronization schedule. So clients send updates at every round, whether the environment is changing significantly or not. The main issue here is that it can lead to congestion. In contrast, AFDQN can adapt its synchronization and aggregation behavior based on environmental stability. During relatively stable SINR and interference conditions, it can avoid unnecessary rounds of updates, which reduces uplink and downlink communication overhead. That makes it much more private.
I'm so sorry to interrupt. You have about 30 seconds left.
Okay, thank you. And we have some limitations that as of now, we assume that the federated rounds will have good connectivity that may or may not be there. The Byzantine vulnerabilities have not been catered, and the jammer constraints that are there are quite well defined, but still they are not exhaustive. In the future, we can say that the work provides a strong foundation, but there's a clear scope for improvement, and few of them are there. We are working like the 5G and 6G tactical waveforms, and finally getting the hardware in the loop and putting it into the software-defined radios. With these extensions, the proposed framework can evolve from a promising simulation-based solution into a practical and resilient approach for the next generation tactical spectrum management. Thank you very much for your attention. Ma'am, I'll be happy to take on your questions.
Yeah, actually a very good topic that you have chosen over, and you are
Thank you,
working long back. That sounds good. Yes, actually the work is almost done, but the few questions related to your future work. Is there any plan to integrate the multi-agent reinforcement learning like AGI or agentic AI?
Ma'am, we
In the
are actually
future.
working on that in the future, I'll tell you, ma'am, because the research has gone much ahead of this point where we did it. we are trying, but ma'am, the main issue in electronic warfare is the overhead. The bandwidth is so low at that point that we cannot just give anything more. As of now, any agentic AI at least doubles up the
Yes.
bandwidth requirement at that point. So that is what is causing an issue to us. But mostly, as of now, we are focusing on translating it from a Wi-Fi network to a 5G or 6G network so that it becomes realistic, and then getting it onto a SDR and trying it online that yes, is it going to work or not, or will it just remain a theory? Our aim is to get it into a practical protocol which starts working for all of us. Because if you know, the electronic warfare is what is happening now, and that is where the focus for all of us is.
Also, one more query that how you ensure your model will secure all the updates and data privacy?
Ma'am, data privacy as of now, we have not used any encryption. To be very frank, I have not done that. We are proposing to do it, but in the next models that we are working, we have a six uh, channel or 6 pointers for what do you call the state vectors, and we are using Byzantine methods. There are 6 Byzantine methods to detect these things. So the work is already on, and then we are seeing that how we will be able to detect. So there'll be different things that will be part of the next paper that's coming up. So we are already on this 6 different type of Byzantine methods we are working on as of now.
Good, very good.
Thank you, ma'am.
All right, so we'll move to the next presentation now. Next, we will have Doyle Shri Bhui, who will be presenting an IoT-enabled system for predictive analysis of cardiovascular disease. You may now begin your presentation.
Yes, ma'am. Is my screen visible, ma'am?
Yes, it is.
Okay. Good afternoon, everyone. My name is Dolshi Bhui, and I'm presenting our work titled An IoT-enabled system for predictive analysis of cardiovascular disease from the Department of Information Technology at Technome in Salt Lake. So as you can see at the bottom, that our system achieves a 93.33% accuracy, an AUC score of 0.97, fits within 42 KB of memory, and runs in under 10 milliseconds, all on a resource constraint microcontroller. So here's a quick roadmap of what I'll cover today. Let's start with the problem. Like, cardiovascular disease is the #1 cause of death globally, claiming over 15 million lives every year. Despite this, most patients are diagnosed only after a certain symptoms become severe, missing the critical prevention window entirely. So there are 4 persistent gaps that our work addresses, particularly late diagnosis. Like, traditional methods simply aren't fast enough. Second, deep learning models like CNNs and LSTMs are computationally heavy to run on the kind of low-cost microcontrollers that are in wearable devices. Third, interpretability. Black box models don't explain the decisions, which is kind of like a legal and clinical problem. And the fourth, most IoT papers claim edge deployment but never actually verify that the model fits on the target hardware. These are mostly the gaps that our work addresses. So our proposed approach is what we call a deployment ready. Rather than claiming the model runs on IoT hardware without proof, we train on the Cleveland Heart Disease dataset to ensure clinical reliability. And then we run a software in the loop analysis to verify the model that it genuinely fits within the constraints of our Arduino Uno or not. Our system follows the standard 3-layer approach, which we have shown here. First, the perception layer. It collects data from sensors like ECG module, SpO2 sensor, and blood pressure module. The network layer relays that data, and the application layer is where our SVM runs inference and generates clinical alerts. This work has 4 contributions: a high accuracy SVM, a fair same dataset comparison with XGBoost and 1D CNN, a sharp explainability, and quantified edge visibility. Next, we have our dataset. We use the Cleveland Heart Disease dataset from the UCI Machine Learning Repository, the gold standard benchmark for CVD prediction research. It starts with 303 raw records. After removing rows with the missing values in the CA and THAL columns, we have 297 clean records across 14 physiological features. The class distribution is reasonably balanced, 53.9% healthy and 46.1% disease. So we used a stratified 80/20 split without any artificial oversampling. The 5 most clinically significant features are shown in this table. As you can see, there are thalassemia, major vessels, chest pain type, ST depression, max heart rate. Next is our methodology. For our main classifier, we trained a soft margin SVM using grid search CV with 5-fold stratified cross-validation. We search across regularization parameters C, kernel coefficient gamma, and 3 kernel types. So we used multiple types of cross-validation, and the winning configuration was C being 0.1, gamma being 0.1, and a sigmoid kernel wins here. A wide margin. A sigmoid kernel is basically a wide margin, mildly regularized boundary that suits the small dataset well, where deeper models tend to overfit. So, to satisfy the reviewer requirements for modern baselines, we also trained XGBoost and a 1D CNN on the exact same database. Same split, same pre-processing, a strictly controlled comparison. XGBoost was tuned via grid search CV. The CNN used two 1D convolutional layers with global average pooling and dropout. For explainability, we applied SHAP's kernel explainer on a 50 sample background set. SHAP assigns each feature a directional contribution score per patient. This satisfies the EU AI Act's right to explanation provisions for high risk medical AI. So it's completely transparent. Our experimental results. The optimized SVM achieves 93.33% accuracy on the 60 sample test set with AUC score of 0.97 and average precision of 0.96, confirming a strong discriminatory power at all decision thresholds. Looking at the classification report, a precision for the disease class is 0.95, recall is 0.88. Across the full test set, there was only one false positive and 3 false negatives. Critically important in a clinical context where false negatives carry the higher cost. To confirm generalizability, we ran a 5-fold stratified cross-validation on the full 297 record dataset. The mean accuracy was 92.9% plus or minus 1.3%, closely matching the held out test set, which tells us the model isn't benefiting from a lucky random split. Next, we have our SHAP results. Now, for explainability, this bar chart shows all 14 features ranked by their mean absolute SHAP value. In other words, how much each feature on an average influences the model's predictions. The top 3 are THAL at 0.118, CA at 0.085, and CP at 0.076. These are completely consistent with established cardiology knowledge. Thalassemia, which is THAL type, is a direct marker of myocardial perfusion impairment. Number of major vessels colored reflects coronary artery disease severity, and chest pain type is the primary clinical symptom. What makes SHAP especially valuable here is that it doesn't just give us global rankings, it gives us directional per patient scores. For example, a reversible thalassemia defect pushes the prediction strongly towards disease, while a normal result pushes it away, like the person is healthy. A clinician can look at any individual patient's prediction and understand exactly why the model chose that call. That is why the EU AI Act requires. Next, we have our comparative analysis. The bar chart shows 9 models from lowest to highest accuracy. Our SVM, shown in coral at the top, 93.33%. Against our own baseline on the same dataset, we beat XGBoost by 3.33% points, 93.33 versus 90.00. And our AOC is higher too, 0.97 versus 0.95. And we do it with a model that is 4.3 times smaller against a 1D CNN. We win by 5 percentage points with a footprint that is 28.6 times smaller and latency that is 6 times lower. CNN's convolutional inductive bias simply doesn't help on 14 independent clinical measurements. Against published literature, We outperform the LSTM at 92% and Health Fast Light GBM at 91.8%, both of which additionally require GPU or cloud infrastructure, making them incompatible with edge deployment. Next is our edge deployment. This is one of our key contributions, actually proving the model fits the hardware. The Arduino Uno has an Atmega 328P processor running at 16 MHz, 2 KB of SRAM and 32 KB of flash. Our SVM, serialized to a static C header file using the mlearn library, occupies 42 KB that fits within the flash with no operating system required. The interference latency of under 10 milliseconds is negligible relative to the 4 millisecond sensor sampling period at 250 Hz, so the classifier introduces absolutely no pipeline stall. By contrast, XGBoost at 180 KB exceeds the flash and the CNN at 1.2 megabytes isn't even close. Both would require external storage or complex quantization. The SVM is the uniquely appropriate classifier for this hardware target. Next is scalability. We also address the path from this benchmark to real-world deployment across 4 dimensions. On scale, the SVM stays competitive up to around 10,000 records. Beyond that, a quantized XGBoost model is the planned upgrade. For real-time streaming, a sliding window accumulator on the Arduino aggregates sensor readings into 14 feature windows at 250 Hz, invoking the SVM each cycle using only the 42 KB model and an 8 KB buffer. For distributional shift, a periodic recalibration of the standard scaler will handle that, and our planned federated learning extension will adapt to local patient populations without centralizing the raw data. Next, we have our future scope. Our immediate task is flashing the serialized SVM onto the physical Arduino Uno, which is currently a prototype, and validating latency on live sensor data. In-date quantization will then push the footprint below 30 KB. In the near time, we'll explore SVM LSTM hybrids for raw ECG time series on another dataset, PTB-XL and Mimic 4. And long term, the federated learning framework and SHAP clinical dashboard will bring the system to a regulatory submission readiness. So to summarize, this work delivers 4 things. State-of-the-art accuracy, 93.33% accuracy, AUC 0.97, confirmed by cross-validation, beating both XGBoost and CNN under identical conditions. Then we have our clinical explainability, per patient SHAP attributions, satisfying the EU-AI Act requirements. Edge-ready deployment, 42 KB under 10 milliseconds on an Arduino Uno, and a scalable framework with a clear pathway to clinical deployment. Together, these establish a reproducible, interpretable, and hardware feasible approach to proactive cardiac care. So, thank you. Thank you very much. I'm happy to take any questions. Our corresponding author's contact is on screen if you'd like to follow up as well.
How we ensure the patient data privacy and security?
Yes, ma'am.
Patient data privacy and security. How you will ensure in this IoT
Actually,
environment?
I can't make your voice. It's a little unclear.
Now, is it audible?
Yeah. Yeah, this is better.
So how do you ensure that patient data privacy and security in IoT environment?
Yeah. About that, we have addressed the situation of privacy with our patients. So that is what the EU AI Act addresses. It basically overlooks that the patient data does not go to a centralized manner. It stays within the model that the patient has. So, like we've also used calibrated sensors with a periodic recalibration. So when we apply sampling synchronization, we use a standard scaler to avoid distribution mismatch. Also for data integrity, we have used an encryption called TLS and SSL plus checksum, which is CRC. So we've also applied edge buffering for continuity. So all of these things, they ensure that every data, a patient's particular personal data, stays within it does not even come to us, it stays within the model.
Have you contacted for any hospital
Yes, ma'am.
regarding this? for
Can
your
you-
work? Have you contacted to in the hospital?
I'm sorry, ma'am. Actually, I cannot understand again.
Have you contacted?
Hello. Um. Hello. Can you hear me?
Yes, we can. I think ma'am has lost her connection.
Okay.
All right, Dolshi, I think you can stop presenting. We'll move on to the next presentation.
Okay, ma'am. Thank you.
Thank you. So, up next, we have Anjali Yavatkar, who will be presenting Digital Transformation in Healthcare Workforce Management, Implications for Retention in Allied Healthcare Services. Anjali, you may now begin.
Good afternoon, everyone. Am I audible?
Yes, you are.
Yeah, my screen is visible.
Yes, it is.
Okay. Myself, Anjali. I'm present. My title of paper is Digital Transformation in Healthcare Workflows Management Implication for Retention in Allied Healthcare Services. I'm working under guidance of Dr. Hemlata Gaikwad. Introduction. The Allied Healthcare Retention Crisis. The core problem is allied healthcare professionals like nurses, lab technicians, pharmacists, and physiotherapists are the essential pillars of the Indian hospital services. It has been observed that the severe shortage, fueled by the high attrition rate and low job satisfaction, overworkload, and the limited career growth. The catalyst is COVID-19. At the time of pandemic, identified the occupational stress and the infection risk expose the urgent need for the innovation of workforce management and the retention strategies. Uh, for this, the help of digital transformation, utilizing the ICT, big data analytics, and the IoT to maximize and the forecast workforce trends, automate the workflows to reduce the burnout. What is the research goal is in exploring the link between the tech-based practices and the increased job satisfaction and organizational commitment. My research objective is the map technologies identify the ICT, big data, and IoT tools relevant to the workforce management, synthesize the evidence, extreme how this technology impact the job satisfaction and the organizational commitment. I've developed a framework, create a theory-driven model, predict the reduced attrition risk, policy recommendation, provide the actionable strategies for the hospital administration policymakers. Now, the theoretical foundation for this is technology acceptance model, TM, utility and ease of use drive the adaptation of new digital HR tools, job demands resource, JDR theory, technology acts as a resource to buffer the demands of heavy workloads and night shift. So, social access theory, when organization provides supportive digital tools, employee reciprocate with the increased loyalty and commitment. I've done the literature review, ICT applications, digital rostering and e-learning recognition tools reduce the complex, boost the field. Big data analytics transitions HR from reactive to proactive by predicting the attrition trends through the absenteeism and the engagement metrics. Internet of Things, wearable and sensors monitor physical fatigue and workload in the real time, allowing the dynamic staffing and safety. Digital wellness, mental health apps, automated credentialing reduce the administrative stress and burnouts. Methodology approaches interrogative conceptual review methodology, search strategy, systematic search across the PubMed, Scopus, IEEE within the 2000 to 2025 database. Also, the global context analysis from the 34 countries, it has been observed that not enough staff, that is, 42% of the staff facing the retention issues. Synthesis finding the organized by technology type of translated to TM, JDR, and the social excellence lenses. Inclusion criteria, allied healthcare professionals, lab technicians, nurses, pharmacists, etc. Scope ICT, digital HRM, big data IoT, and wearables. Time frame 2000 to 2000. Key metrics is jobs satisfaction, burnout, retention, organizational commitments. Study type is empirical studies, conceptual paper, and the systematic reviews. Context, healthcare setting with focus workflow stability. This is the conceptual workflow, ICT applications, IoT solutions, big data. With the theories, reduce job demands, increase in job satisfaction. It strengthen the organization commitment, increase the workflow retention, and quality of patient care. Implementation of roadmap, phase 1 foundation, deploy the digital roster to the eliminate scheduling conflicts, launch a mobile e-learning modules for the immediate professional development, integration medium term, implement IoT wearables in high stress departments, radiology and ICUs to the monitor physical fatigue, establish the digital wellness platform for anonymous stress tracking and mental health support, intelligence, integrate the big data dashboards to analyze turnover patterns, use predictive analytics, trigger intervention alerts when the staff member shows high attrition risk. The strategic impact for the employees, reduce burnout, balance workload via IoT monitoring, empowerment, transparent career paths, ICT-based skill tracking. For the organization, cost effective, lowering the high cost of constant recruitment and retraining, data-driven culture, shifting from reactive crisis mode to proactive workflow planning. For patient quality of care and accessibility, stable, satisfied leads to the fewer clinical errors, better patient outcome. Discussion and practical implication. Start smart, implement the high impact, low friction tools, digital rostering and e-learning. Safety first, pilot IoT wearables with clear consent to manage the fatigue. Proactive management, use big data, identify at-risk staff, they resign. The human element, technology only works if it's improve the daily experience of the staff. Conclusion and future research. Summary, digital transformation is not just patient outcome, it is a vital strategy for workflow stability. Key takeaway, integrating ICT, IoT, and big data reduces burnout and creates clear career pathway. Future direction, empirical validation of the framework in Indian hospital, integrated AI personalized professional development, addressing the ethical privacy concern regarding the employees monitoring. That's it from my side. Thank you so much. Open for questions.
Yeah, Anjali. So, what are the limitations of your study?
So, ma'am, limitation is it has been observed that for this, so much of study is done for the nursing and the doctor's retention. It has been observed the study is not done for the allied healthcare professional. And actually, in India, there is implementation of a digital platform is not yet started. So that is the problems I have.
Okay. So, is this software or the system you are proposing over here is implemented?
Ma'am, I'm not able to hear you.
Is your system is implemented?
No, ma'am. It is not implemented. It is a conceptual model.
Oh, fine.
All right. So now let's move on to the next presentation. Next up, we have Jaikumar Gandharva, who will be presenting Evaluating Prompt Design Strategies for Large Language Model-Based Code Summarization. You may now begin.
Hello. Hello.
Yes, you're audible.
Uh, Good morning, everyone. Today I am presenting a research work entitled Evaluating Prompt Design Strategies for Large Language Model Based Code Summarization. What was the motivation behind it? Understanding large code bases is really time consuming, especially when documentation is missing or outdated. Developers often spend more time reading code than writing it. Automated code summarization helps by generating short, natural language description of the code. Recent large language models perform this task without fine-tuning. However, the key point is the quality of output depends heavily on how we design the prompt. Research objective. So our main objective is to evaluate how different prompting strategies affect the quality of code summaries. For this, we use two models, that is DeepSeek, Coda, and Llama, five prompting strategies, and three languages, that is Python, JavaScript, and Java, and Codex Flu dataset. Related work and gap earlier work, researchers focused on models like Cobert and Code5. Most approaches rely on fine-tuning or architecture improvements, but there is a gap. We can improve performance without fine-tuning just using prompt engineering. So our works focus on a control comparison of prompt strategies, and that too by skipping the commercial APIs running on the local server. The methodology, we designed a pipeline where code is given as an input, different prompts are applied, models generate summaries, and outputs are compared with the ground truth. For that, we had an experimental design structured like 2 cross 5 cross 3, that is two models, five prompts, and three languages. We kept the model weight fixed and ran everything locally using the Ulama software. So the only prompt change is making our study controlled and fair. We use total five different prompting strategies. The first one is zero shot, that is with no examples, few shot, which is studied with few examples, chain of thought, that is step-by-step reasoning, and critic base, which generates and refines, expert guided, which works like a senior developer. Our key idea was prompt structure directly affects how well the model understands the code. For that, we used dataset, that is Codex Flu, and the Python language had 2.5 lakh plus samples. JavaScript had 50,000 plus samples. Java had 1.6 lakhs per sample. Pre-processing included deduplication, formatting, clarified sampling, which ensured balanced and clean data. Evaluation matrices, we used four matrices: Blue, Raugel, Semantic, Meteor, and Bird score for semantic. These metrics jointly captured both word level overlap and deeper semantic meanings. For the overall results, as a conclusion, Llama outperformed DeepSeek in the most cases. Few short prompting gave the best results. Chain of thought gave the second best. JavaScript was the hardest language. The main takeaway from it was prompt engineering significantly improved the performance. We have the major highlight scores on the screen. If we talk specifically, the Llama performance was strong and stable one. Best results with few short, chain of thought, improved reasoning. It handled Python, Java, and JavaScript even better than DeepSeek. These are again the highlights of the experiment. For the DeepSeek performed best on Python with zero shot, but struggled with JavaScript and Java language. Showed high sensitivity while we changed the prompts. So overall, it was less consistent. Our main key findings were prompt engineering can replace fine-tuning in many cases, and as I mentioned, with skipping a commercial APIs. And the few shot was the most reliable one from the prompting strategies. And JavaScript was the most challenging for the whole experiment. We had limitations like dataset contains only short code. We only experimented with the basic three languages, etc. As a conclusion, prompt designing was not a small detail, it is a core factor. Few shot and chain thought were the most effective ones. Llama outperformed DeepSeek, and the most importantly, prompt engineering is like very practical and scalable alternative to the fine tuning. Thank you.
I have one question that which programming language you considered over here in your work?
In our work, Java, JavaScript, and Python.
Okay, why you have chosen only this three?
Sorry.
Why you have chosen this only? Is there any literature work or have got through the literature work that
Yeah, we
these
have worked.
languages
We have gone through literature work through the already published research papers in the recent times, 2025, 2024, which was similar to this, but they were using commercial APIs. And the weak point of commercial APIs is, for example, if I'm using my if I build this into a proper deployed software, I can use it locally for any my companies or any of the industry. But when I'm using commercial API, my whole data goes to, for example, I'm using ChatGPT or anything, they will have the data of my company too. But our model skips the commercial API and we can also run it locally. And that's the plus point of the whole thing. And we are just including more languages in it.
We have explored this automatic prompt optimization.
Sorry.
Have explored automatic prompt optimization. Have checked these things conceptually.
Automatic code optimization.
Oh yeah, prompt optimization, not a code optimization.
Like not exactly, I could say that our focus was on like manual and control comparison of the predefined data set.
You can explore these things because in this model you
Sure, ma'am, I'll note it down.
to be added. Okay. Yeah.
Sure, ma'am, I'll note it down. Thank you.
Yeah.
Thank you, ma'am.
All right. So moving on to the next presentation, we have Sachin Kumar who will be presenting GAHS for e-commerce, a generalized authority hub score for evaluating product search query expansion on unseen queries. Sachin, you may now begin.
Yeah, thanks for the introduction. Let me start sharing my screen. Is my slide visible? Is my screen visible?
Just a second.
Yes.
Yes, it is.
Yes.
Oh, okay. Yeah, thanks everyone, and thanks for the brief introduction. So myself, Sachin, I'll be presenting GAHS for e-commerce, generalized authority hub score for evaluating product search query expansion on unseen queries. This was an independent work that I was doing in my own time outside of my company. So what GAHS is, this work basically addresses a fundamental gap we have in evaluating the modern search systems, where we do have metrics for evaluating the query expansion, but this is a new unsupervised metric that is evaluate the query expansion in product search. specifically designed for the queries that we've never seen before. So to start with the core problem, there is a vocabulary mismatch problem, specifically in context of e-commerce search. So shoppers and product catalog, they do speak different languages. So like, for example, a user searching for summer dress won't find an item which is if the dress is listed as a fluorescent dress with spaghetti straps. Similarly, a comfy sofa won't match a three-seater upholstered love seat. So this vocabulary mismatch is very much prevalent in e-commerce. So query expansion is an approach that bridges this gap by appending or reprioritizing search terms to better aligns with buyers' actual intent. Now, there are a variety of methods which ranges from traditional pseudo-relevance feedback to modern LLM-based approaches. So, but a query expansion, it's also kind of like a double-edged problem. So it can introduce query drift. So where expansion terms can skew the results away from the original intent. So there is one concrete example. So if running shoes return mostly Nike results, a PRF or pseudo-relevance feedback system might inject Nike into expanded query, which will hide all the other brands. So it affects the supervised as well as LLM-driven methods. And standard metrics like NDCG are very much agnostic or very much blind to this query drift. A system that can narrow to one brand can still score perfectly on NDCG if those branded items happen to be labeled as relevant. Now, this brings us to the evaluation gap that we are trying to address with this paper. So the fundamental problems exist. So there is a Cranfield paradigm, so that require pre-compiled or relevance judgments. So you can't compute a MAP or NDCG scores for a query that you have never seen because you need relevance judgments for that. Secondly, even when you have judgments, these metrics cannot detect query drift, as I was just explaining in my earlier slides. Now, third alternative do exist is A/B testing and user surveys, but those are really slow and very expensive. So e-commerce search engines, they do encounter novel queries, and we need an unsupervised annotation-free metric that can work out of box for any query. And that was what like the proposed solution for this paper addresses. So why not we just use the MAP or NDCG scores, which are very much commonly known information retrieval matrix. So they both require relevance judgments. They cannot operate on unseen queries, and neither can detect the query drift. So GAHS fills that gap. It works without annotation, detect drift through the graph coherence, and can scale to any query. The only trade-off is it cannot capture the graded relevance, structural coherence, which is a complementary signal. So then coming to the proposed solution of this paper, which is GAHS, Generalized Authority Hub Score. So key hypothesis is here is it's a simple and very much powerful. So a good query expansion should retrieve products that form a coherent, tightly knit community within a product graph. So we can model the catalog as a graph where products are connected by shared brands and category, and then apply HITS algorithm, which is hyperlink induced topic search algorithm, to measure the authority scores. So it's fully unsupervised. There no human annotations needed, and it's a graph based. So using the existing catalog structure as a quality proxy. And most importantly, it's drift sensitive. So it's a fragmented, disconnected retrieval will get a lower GHS scores. And that is something I'll be explaining in the later slides as well. So GHS algorithm is based on the HITS algorithm. So I'll give a brief introduction. So HITS algorithm, also called as hyperlink induced topic search algorithm. So what it does is basically assign two scores per node, authority and hub. So authorities are nodes pointed to many good hubs or the products which are very much central to a coherent cluster. So hubs can point to many good authorities produced with products bridging subcategories. And now the update rules here could be mutually reinforcing. So you can initialize both to one, iterate, normalize, and converge. So this is something like a repurposed it for a product relationship graphs, specifically for the e-commerce context. Now, this is an example product graph. So products are nodes and edges connect products sharing the same brand or category. Like for example, Nike Air Max shoes connect to Nike Pegasus through Nike brand and to Adidas Ultra through shared running shoes category. So a coherent retrieval here will pull the products from this tightly connected cluster, whereas a drifted retrieval will pull the disconnected nodes from unrelated parts of the graph. So this is just to give like an intuition around like how the product graph could be structured and how it could be helpful. Now coming to the GAHS, so it's a four-step pipeline. So starting the first step, we feed the query through a query expansion method and retrieve the top K products. And this is something we can call it as a root set. Second thing is expand this into a base set by pulling in graph neighbors. So graph neighbors could be products connected by shared brand or category. Nodes being products and edges means product sharing the same brand or multi-category proxy. Now, this expansion is necessary because HITS needs local density to compute reliable scores. Next is we run the HITS iterations on the base set until convergence. And finally, we compute GAHS as a mean authority score across the root set products. Now here, higher GAHS score means coherent expansion and lower score signal drift or fragmentation. Now there is another variation of it, which is rank weighted GAHS. So rank weighted could apply logarithmic discounting like NDCG, top ranked products contributing more and vice versa. So this will be more sensitive to drift where relevant products might get worried. So this is something like I also proposed later on in the slide as a future work. One example for the GHS, so we have like wireless earbuds. So wireless earbuds can expand to Bluetooth headphones, noise cancelling. Now, top 5 results could be AirPods, Sony, Jabra, Samsung, or Bose. Now, base set will add 25 neighbors. HITS gives like a high authority scores because they're tightly interconnected. Now, contrast this with the expansion drift to wireless charger. You can get only the phone charger and laptop docks disconnected from the earbuds cluster, which will have like GAHS score as 0. So this is a kind of a signal that we are trying to capture. And just to draw the contrast, like with or without GAHS, how it will fare out for this query. Now, moving on to the experimental setup for the implementation. So for experimental setup, I used the Amazon ESCI dataset. So Amazon has an ESCI dataset where they have like a labeled product query examples as well as the classified categories for the products.
I'm
So
so
this
sorry to
benchmark,
interrupt. Sorry,
yeah.
but you have about 1 minute left.
Oh, okay. I'll speed it up then. So for the experimental setup, actually partitioned into a scene set and query set. And the query expansion methods actually used no expansion as a baseline and and the product relevance feedback and semantic BERT as well as generative LLM-based approach using Gemini with chain of thought prompting. Now, the research question that we are trying to answer from it is, does the GHS produce consistent rankings with NDCG scores and whether it's reliably differentiate the query expansion methods? And does the query expansion method associate with, do receive the lower GHS scores? So for the first research question, we do notice that it is kind of discriminating. It is correlating with the standard matrix, which being MAP and NDCG scores across the 4 query expansion methods. For the second research questions on the unseen queries, GHS actually does produce a discriminative power, basically correlating with the earlier scores, where generative was performing better for the generative query expansion method as compared to the semantic based approach or the PRF based approach. Now, for the research question 3, for the coherence sensitivity, GHS was correctly assigning higher scores to methods which are anchored in the catalog structure. Now, the key finding here is the PRF is query dependent, and expert introduces domain appropriate terms. So that's why we are seeing, for the scene set, the semantic score was performing better than the PRF on both MAP and GHS. Now, the real world impact, it can reduce annotation cost and provide, have a faster monitoring and faster query expansion iteration. Now, limitations, they're a simplistic graph with brand and category ages and hits overhead with respect to offline evaluation. The future approach, as I was mentioning earlier, so there could be content-aware GHS or rank-weighted GHS, and live A/B testing validation is needed also against the conversion KPIs. So these are the key takeaways, and with this, I'll conclude the presentation and move on to the questions part. Thank you.
I have one question related to what strategy you used to handle unseen or low frequency queries, low frequency type of queries.
So if I understand question correctly, so you're saying like for the unseen, how you validated? Okay. So for unseen queries, sorry.
Continue.
Oh, okay. So for unseen query set, so I was using Amazon ESCI data set. So for that, actually, I do also had like relevance judgments for those. So for those relevant judgment set, there was one set actually for which I created a product graph, and there was another set which was unseen to the product graph, but I already had judgments for those. So while I produced the examples, while I produced the results, so there I checked with the relevance judgments, or the scores are correlated with what we have as a tagged relevant product categories or the products available for it. So for unseen query set was used for the product graph, unseen query set was unseen to the product graph. So that's why, but I already had relevance judgments for those because that was like a labeled data set.
Okay.
All right, moving on to the next presentation for today. We have Manav Thakkar, who will be presenting machine learning-based emotion recognition using passive smartphone sensors for music recommendation. Manav, you may now begin.
Am I audible? Hello?
Yes, you are.
Thank you. Screen is visible. So, good afternoon everyone. My name is Manav Thakkar, and today I am presenting my paper titled Machine Learning Based Emotion Recognition Using Passive Smartphone Sensors for Music Recommendation. In simple words, we detect how you feel using your phone's inbuilt sensors and automatically play the right music based on the emotion that it can get. No variable or no manual input is needed in the system. Let me start with the problem. The thing is, today emotion awareness systems are there that fall into categories but with serious drawbacks. One of the major drawbacks is it uses all camera based system which can breach the privacy of the person, or the thing is it uses variables like EEG or ECG variables which are hardly available for any person on daily use basis because they are expensive to use. The third thing is some app asks user to manually lock their mood, which we will not like if you want a seamless transition of music. The key insight is every Android smartphone already has the passive sensors with for example the accelerometer, gyroscope or light or proximity temperature, which are running silently 24/7 on the back of the phone. So we can use that with zero extra cost or zero use effort because they are already present in the phone. The key contribution of my paper will be, we are making 5 primarily key contributions. The first one is we are the first system to detect emotion using only passive sensors with no camera dependency or no variable requires. The second is we are using 16 class of emotions which are built on Russell's circumplex model. 4 are main emotions and the 4 are each emotion subcategories. So that concludes with 16 different emotions at a time. The third one is we recommend music in real time from DEEM data set, which is already a verified and trusted database set for music testing purpose, which contains 1802 scientifically emotional labeled song based on valence and arousals. Then the fourth is we are using a 2+2 strategy, which is like there are four songs. When the emotion is being understood by the model, it will give you 4 songs. 2 of them will be old songs which are already similar, which you have already heard, and 2 will be the new one. So it's kind of mixing old with new so that the user will never get bored of it. And last one is we are validating the entire system based on real Android device for 7 continuous days, which for overall we have connected over 9,000 samples, and we also tested it in the system. The system architecture is a simple one. The Android app pulls all 6 massive sensors each 5 seconds, because 5 seconds in the window gap for each and every sensor to get detected and being stored completely in the background. The raw sensor data is sent to our random forest classifier, which predicts the user current emotion from 16 possible classes. One important design point here, our system supports an optional camera fusion mode. If the user grants camera permission, the system blends with 80% facial emotion and with 20% of sensor data. The camera gives accurate static snapshot, but if it is only possible if the user wants to use it, or it can even be used without camera too. It tells you precisely what the face shows at the moment, but the sensors are always running in the parallel, provides a seamless, dynamic, continuous, updated emotional signal every 5 seconds. This means even between camera reads, the system never loses the track of emotion states. If the user denies camera access, which is common because nobody wants to use camera for just playing the music they want to hear, the system falls back entirely on the sensors. As our results show that the sensors have alone achieved 96.39% accuracy. Once the emotion is classified, a Flask REST API queries the DEEM song database and returns the match tracks with the queue of continuous seamless transaction. For each model, we have used Russell's circumplex model, which is established in the psychological framework. It defines human emotions along with 2 axes: valence, which is how positive or negative you feel, and arousal, which is how energetic or calm you are. The 2 axes create 4 quadrants: happy, sad, angry, and calm. We further divide each quadrant into 4 sub-emotions, giving us 16 classes in total. Each of the DEEM songs has its own position in the valence and arousal space. When our model predicts an emotion, we find the song closest to the point using Euclidean distance, which gives musically and emotionally appropriate match. For training, we have used DEEM datasets. As you can see from the scatter plot, the songs are distributed widely across the valence and arousal, which means our recommendation system fully covers all emotion ranges. Since sensor data is collected from 16 classes, it's challenging. We use Gaussian noise augmentation to double our training samples from 1800 to 3600. We have used 80-20 train and test split. The model inputs is 6 sensor derived features and output is one of the 16 emotion class that is labeled. The classifier results. The results are strong. Our random forest model has achieved the accuracy over 95%, which is with an F1 score of 0.97. For comparison to the KNN baseline model, reach only 65%. This is a 30% point improvement. To confirm this is not a lucky split, we ran file-fold cross validations. This result 96.39 plus or minus 0.41%. An extremely low variance, which means the model is consistent and stable across all the folds. Looking at the feature importance on the chart on the left, The three most important sensor features are accelerometer, gyroscope, and ambient light. Ambient light. This makes intuitive senses. how much how much you move, your environment, brightness, and your body rotational activities are all strong natural indicators of your emotional state. In real world evaluation, beyond the lab, we ran app on the real world Android phone for 7 continuous days with zero manual input from the user. The system passively collected all the data and loaded it into CSV file. The scatter plot on the left shows all the samples that are distributed across valence and arousal spaces. You can see the clear clustering patterns that correspond to natural daily emotion rhythms. In the term of emotion distribution, 54.8% of the time the user was detected as calm, expected since the phone is often resting, and the other were sad when the predominant late nights hour was working, and which aligns with the natural human behavior, and 16.6% were happy, correlating with the period of physical movement, and 4.9% was angry. The real world distribution is emotionally coherent and matches what psychology research tells us about daily mood patterns, which validates our sensor based approach beyond just a test accuracy. In conclusion, to summarize our work, we built a first system that detects emotion using only passive phone sensors and recommends music automatically with no camera dependency or no extra hardware. We have achieved a worthwhile accuracy over 16 emotion classes, validating over 9,000 samples over 7 days. For future work, we plan to collect a multi-user labeled sensor database, explore deep learning models like LSTM and CNN on raw sensor streams, introduce personalized adaptive sensors for personalized adaptive sensors waiting, and integrate with live platforms like Spotify. Thank you.
I have one question. How do you ensure this user data privacy while collecting the sensitive behavioral data?
Ma'am, the thing is, when you collect the data from the users, it only collects the data of gyroscope and accelerometer and the basic passive sensor. We do not show what the phone is doing or what activity is basically going in the phone. It shows that the phone is active or not. So even the location concern or the camera concern or any data breach concern is being neglected with using the passive sensors.
And how your data is processed locally or send it to the cloud side?
Sorry, ma'am, I can't hear you.
How data you processed?
How data is
Data
processed in the
processing. Yeah.
model? Okay. So basically, first of all, when we collect the data, it's collected in the basic CSV file in the phone, and then we send the data through the flash server, and it is being processed. It is being processed through the model which we used. First, we use KNN model.
Is there any data pre-processing techniques you applied in between or no? Let's
No,
have
we
you
have not
checking the
applied
missing
the data
value, null value, or anything?
No, ma'am, because like when I worked for the sensors, there was no missing values in the till date. When I'm working, the values are always coming there.
You are converting sensor data into the CSV, right?
Yes. So each 5-second window gap, the data is collected like for the accelerometer movement, the gyroscope movement, the ambient lighting, even the phone is off or not, the battery temperature. These are the passive sensor data. Each and every 5 seconds, these data are being loaded into the CSV file. So till now, I have not found any missing data or any NA values in the data.
But you need to be precautionary, need to be apply these things, data pre-processing. Sometimes the device may get failure in between. So that
Surely,
then
ma'am.
these things may happen or delay may happen due to the network lags. Okay.
Surely, ma'am. I will consider that.
Okay. Next. Thank you.
Thank you, ma'am.
Our next presentation for today is by Sheikh Suhail Ahmed, who will be presenting privilege escalation in Linux using a kernel-level credential monitoring module. You may now begin.
Yes, am I audible?
Yes, you are.
Yeah, just give me a minute. So yeah, is my screen visible?
Yes, it is.
Okay. Good afternoon, everyone. I am Sheikh Sohail Ahmad, and today I will be presenting a work titled Linux Kernel Credential Monitoring Module to Prevent Privilege Escalation. So this work has been carried out along with my team members under the guidance of a professor. So in this presentation, I will walk you through how privilege escalation attacks occur in Linux systems, why existing solutions are not sufficient, and how our kernel level approach can efficiently detect and prevent such attacks in real time. So yeah, before going into technical details, let me first give you a brief overview of what I will be covering. So basically, I will start by explaining the problem and its importance, followed by the existing research and the gap we identified. And then I will explain our proposed solution, how it works internally, and finally discuss the results and the conclusion. So yeah, so privilege escalation is one of the most critical threats in operating systems, especially in Linux. So in such attacks, an unprivileged user gains root access, which essentially means full control over the system. So our approach focuses on detecting these attacks at the exact moment when privileges are being changed inside the kernel. So to achieve this, we have developed a Linux kernel module that basically monitors credential transitions in real time. So we specifically hook into a kernel function called commit creds, which is responsible for updating process credentials. So in addition, we designed a policy-based decision system that basically differentiate between legitimate actions such as those performed using sudo and a malicious privilege escalation attempts like set to ID exploits. So our results show that this method is effective, lightweight, and introduces minimum performance overhead. So yeah, now let us understand the problem in a more depth. So in Linux systems, every process runs with a certain level of privilege defined by credentials such as user ID and EUID, which is known as effective user ID. So normally users operate with limited privileges. However, attackers try to exploit vulnerabilities to gain root access. So once root access is obtained, the attacker can do anything like he can access sensitive data, modify system files, install malware, or disable security controls. So the existing security mechanisms such as uh, access control policies and monitoring tools do provide some level of protection. However, they mostly operate in user space, which means they do not have visibility into what is happening inside the kernel. So the actual modification of credentials happen inside the kernel, and this is where most attackers exploit the system. So because of this lack of visibility, many attackers are not detected until after the system is already compromised. So this is the core problem which we are trying to solve. So yeah, so we analyzed several existing research works to understand current solution. Some approaches focus on the kernel data monitoring, where they detect memory corruption or tampering. Other monitor system calls to detect suspicious behaviors. There are also some solutions that try to protect kernel data structures, such as the credential structure itself. So more recent approaches used advanced technologies like eBPF based runtime defense. So while all these approaches are useful, they also have some limitations. Like most of them either focus on protecting data or they detect attacks based on specific patterns. So very few solutions directly monitor credential transitions in real time. This observation led us to identify a research gap. So yeah, this is the problem statement. So based on our study, the main problem is existing Linux kernel security mechanisms. They do not provide visibility into credential changes happening inside the kernel. So basically, attackers exploit these gap by modifying kernel credential structures to gain unauthorized root access. So most existing solutions are either reactive or they are too complex to like we can say deploy. So there is a need for a system basically that can monitor, detect, and also prevent privilege escalation at the kernel level. So yeah, without adding a heavy complex to our system. So yeah, this is a research gap and our contribution. So to address this, we identified a clear gap in existing research. Like there is a very limited work on real-time monitoring of credential transitions using a lightweight approach. So our contribution focuses exactly on this, and we developed a kernel level monitoring system using a Linux kernel module. Yeah, here we used kprobes to dynamically hook into the commit creds function. So this allows us to intercept credential changes as they happen. So on top of this, we also implemented a policy-based mechanism that decides whether a privilege change is legitimate or is malicious. So if this is malicious, the system immediately blocks it. So instead of reacting after an attack, basically we can stop it at the moment as it occurs. So yeah, so this is the motivation. The motivation behind our work comes from three main observations. So the first one is traditional security tools cannot be seen what happens inside the kernel. So the second one is that privilege escalation attacks specifically target kernel credential structures. So and the third one is existing advanced solutions are often complex and are not easy to deploy in real world systems. So here we wanted a design that can act as a solution that is simple also as well as efficient and capable of detecting attacks in real time and without requiring major changes to the system. So yeah, and coming to the methodology here, we implemented our system in an isolated Ubuntu virtual machine to safely simulate attack scenarios. And our architecture consists of basically these four main components: hooking mechanism, and core idea is to intercept the commit creds using kprobes. And whenever a process tries to change its credentials, this function is called. At that moment, our module captures both the old and new credential values. So these values are then passed to the policy engine, which basically analyzes the transition and decides whether it is legitimate or not. So yeah, coming to the workflow, when a process attempts to change its privileges, the kernel invokes the commit creds function, and our kernel module it will intercept this call using kprobes, and then we then extract the old and new credentials such as the user ID and the EU ID, which is effective user ID. So the policy engine evaluates this transition. For example, if a user with UID 1000 becomes UID 0 through a trusted process like we can consider sudo, uh, it is it is to be considered legitimate. So, however, if the same transition occurs through an unknown or a suspicious process, it is classified as basically malicious. So based on this decision, the response engine either allows the process or terminate it immediately. So this ensures that authorized privilege escalation is unauthorized privilege escalation is stopped in real time. So yeah, coming to the model. So here our system can be understood as three main components working together. The
I'm
first one
so
is the
sorry
kernel.
to I'm sorry to interrupt. You have 1 minute left.
Yeah, ma'am, I will submit up. So our system can be understood as three main components working together. So the kernel credential system store process identity information as well as the monitoring module intercept credential changes in real time. So and the policy engine evaluates these changes and it basically enforces decisions. Yeah, this creates a complete pipeline for detecting and preventing privilege escalation. So yeah. And coming to the results, our system performed very effectively during testing, and the legitimate privilege escalation, such as those performed using sudo, were correctly identified and allowed. At the same time, malicious attempts using set UID binaries were detected instantly. Yeah. So coming on to the detection and response consistency analysis. So we also tested the system multiple times in our labs to ensure consistency. So the results remained stable across all the executions. And while coming to the conclusion, to conclude, our project mainly demonstrates that monitoring credential transitions at the kernel level is a highly effective way to basically prevent these privilege escalations. So our solution is very lightweight, does not require modifications to the kernel source code, and it introduces minimal overhead. Yeah, so this makes it practical for real world deployment. So coming to the future works, here we are open to develop a user-friendly monitoring interface and also extend the policy engine to support more advanced rules, which is to be done, and to integrate the kernel module with centralized logging, as we all know, SIM solutions we have, they can extend the capability. So, and the last one is explore compatibility with additional Linux distributions also. So here are a few references that I have added in my slide, and so thank you. So, ma'am, I am open to your questions.
Yeah. Good. Your topic. I have one question. What happened if attacker get the control of kernel level access? Then
Sorry,
can your
ma'am.
system still provide the protection?
So, what kind of attack, ma'am?
If any of the attacker gains the kernel level access,
Yes, ma'am.
okay, so can your system still provide the protection? Have
Yeah,
checked
yes,
or
ma'am.
validated this?
Like here, my system basically differentiates between malicious and the legitimate processes. So, as well as when attacker tries to enter my system, the Linux kernel module will be triggered, and it basically differentiates between malicious and legitimate processes. So, whenever the malicious process is being requested to get the user root privileges, it will be terminated as soon as possible. Yeah.
You have validated these things, right?
Yeah, ma'am. We have we have simulated real-time attacks by ourselves, and we have reported all the readings. So yeah.
Okay. Also, one more question, that how do you balance security over this real-time policy? Is
Sorry,
there
ma'am.
any
Balance what?
encryption? Security? How do you balance the security? Is there any encryption like techniques is available?
No, ma'am. Currently, we have not integrated any encryption right now, so I will note it down and I will let you know.
Oh, future you
Yeah.
have to make sure that these things, right?
Yeah, ma'am. Thank you.
And because you
I
are
will
talking
note
about
it.
the real time, yeah. Oh, good.
Yeah, ma'am. Thank you.
Our last presentation for today is by Menna El Gabri, who will be presenting Tragedy, Trajectory Guided Emotional Dialogue System. You may now begin your presentation. Is Menna or any of her co-authors present today? All right. So in that case, we'll proceed to the closing remarks. Just give me a second. So on behalf of the entire team, I would like to thank our authors for their excellent presentations and contributions in this session, and to all our participants for being a part of this international conference. I hope this session was informative for everyone, and on behalf of the team, I thank you for your support during this 11th version of the conference and all the previous 10 versions. We will be happy to have you in the 12th version in 2027. All the presenters would be receiving their digital certificates via email within the next 2 working days, and the publication will be live in the next 7 to 8 months. Kindly cooperate with the team of ICTIS 2026. Before we end today's session, I would like to thank our session chair, and I would like to present this token of our appreciation to her on behalf of Team ICTIS and Global Knowledge Research Foundation and partners. Thank you so much for your valuable presence, ma'am. Before we end, I would like to request everyone to please turn on their cameras for a quick virtual snapshot. All right. Thank you so much, everyone. The session is adjourned.
Thank you.